Great seeing you here again in this new video. And in this video, I'm going to describe the different probability distributions that we're going to use to calculate PERT and 3-point estimates. First, we're going to look at the basic distributions and what are the basic distributions that we will use for calculating the 3-point estimates. We look at the first distribution, which is the beta distribution. Then we look at the triangular distribution, and then we look at the normal distribution. So these are the three basic probability distributions that I will be using to work with 3-point estimates. So let's have a look at the distributions that we will be using for the 3-point estimations. Now, when we are selecting a distribution, it's very important to find a distribution with the correct form. We try to describe the evolution over time as accurately as possible. And when we look at the PERT evolution and the PERT method, we're going to consider basically three probability distributions: the beta distribution, the triangular distribution, and the normal distribution. Now, when we're looking at other methods to include uncertainty in project, for example, Monte Carlo analysis, we're going to consider other distributions. We're going to evaluate each activity, which is the best corresponding distribution to estimate the duration of the activity or the cost of the activity. So now we are limiting ourselves to the PERT or the 3-point estimation, which is a simpler way to introduce uncertainty in projects. But it has proven success, so this is also something that can be applied very easily in projects. First, we have the beta distribution. The beta distribution is a function or a distribution defined between a minimum and a maximum value, and it also has a form factor. So we can have different distributions between the minimum and the maximum depending on the chosen form factors. And we will look at that later, how we define those form factors. Now, using the form factors, we can in fact define the form of the distribution and select the best distribution for the different activities or for the project. Now, we can apply this on an activity, but we can also apply this on the project. Typically, when we are going to apply the 3-point estimates, we're going to apply them on the different activities. We're going to use the 3-point formulas, but we could also use the beta distribution as such to evaluate what is the best option for every of the activities. The distribution also can include learning curve effects and can also be used to determine the probability of projects being completed within a specific time or cost limit. The beta distribution also assumes that we know the form of the curve, which is not always the case. So when we know the form of the activities and the cost or time distribution of the activities, we can in fact apply the correct form factor on these activities. In some cases, however, we will not know this, and then we will prefer a triangular distribution. It's the same principle like before. We have a distribution which is defined between a minimum and a maximum value, between the range, but now the form is a triangle. And between the borders, the probability density curve has the form of a triangle with a maximum value or mode between these values. And it can be basically skewed to the left or skewed to the right. So these are two possibilities that exist, or it can even be completely symmetrical. It depends on the values. Here we're looking at the minimum value, the maximum value, and the probable value. The probable value will be the top of the triangle. As for every probability density function or distribution, the surface under the curve is 1 or 100%. Like I said, we will use the triangular distribution when we are not sure about the form of the distribution of the activity or the project. It's a simplified distribution and it makes its application easier. Of course, in order to get this simplification, we have to pay for something, and typically the expected values and the standard deviations are higher than when we are considering the beta distribution. But that's the extra security, the extra value we add to compensate for the fact that we don't actually know the distribution. We also have the normal distribution. The normal distribution, or the Gauss or bell curve, is a very popular distribution and is defined around an average value and a standard deviation. So we only have two parameters here, an average value, the mean, and a standard deviation. It's a very interesting distribution because it describes many natural cases, and it is a well-known distribution for project managers and for statisticians and people in many businesses. It's a symmetric distribution, which means that the mode is equal to the median and it's equal to the average or the mean. We will going to use this distribution once we know the expected value of the duration or cost and its standard deviation, and we can use these two to determine or do the calculations using a probability function based on the normal distribution. And we can use this to link the cost, for example, with probability. We can also use more complex models when we have all the exact distributions. We could use a beta distribution or a triangular distribution to do this. But basically, the normal distribution is so well known that a lot of calculations can be done using this distribution, and that's what we're going to use in the remainder of this lesson. That's it about the definition of the basic probability distributions. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye-bye.